So I want to welcome Jessica tonight, who's coming to us from Riverside. And Jessica is doing really important work on the Ridgeways, light-footed Ridgeways rail habitat supplementation. And I'm so eager to hear about that. She has her BA in Science and Biology from Illinois Wesleyan, and her current work at she's a wildlife biologist at the Santa Ana Watershed Association, where she also monitors Bell's vireo and least tern. So she is deep in the business of monitoring endangered species. And I'm so happy that you're here with us tonight, Jessica. And whenever you're ready, you are free to take the helm and start your presentation.
Okay, thank you for the introduction. I'm excited to share my master's project research with you all tonight on facilitating the use of artificial habitat supplementation for the light-footed Ridgeways rail. Can you see the screen okay?
Yeah, it's full screen. It looks great.
Perfect.
Now, I want to just mention one thing. If you have questions during the presentation, go ahead and enter them into chat, and then we will filter through them a little bit later, so Jessica won't have to monitor the chat so much. So feel free to enter questions whenever you'd like, and we'll go over them a bit later.
Okay, so if you are familiar with artificial habitat supplementation, you may think of things like nest boxes for species like tree swallow, and this can be used for pest management, or artificial vernal pools for species like western spadefoot toad, or artificial burrows for burrowing owls. And these are all examples of artificial habitat supplementation for the purpose of supplementing disappearing habitat for imperiled species. Another example of this is artificial rafts for the light-footed Ridgeways rail pictured here, and that's the focus of this project. These rafts supplement both nesting habitat and high tide refugia, or shelter from predation habitat. So first, I'll go into some background on the light-footed Ridgeways rail, or the Ralis obsoletus levapies. They're a secretive marsh bird and a near coastal salt marsh obligate. They're adapted to tidal cycles, so at low tide, you might find them foraging in channels pictured here, and at high tide, they're moving into higher elevation areas of the marsh, preferably with vegetative cover that can shelter them from predation. Many of you may know them as the clapper rail, and you can hear them. They're very distinguished. If you go in the marsh, particularly at dawn and dusk, you may recognize them by their distinctive clappering call. They were split in 2014 from the clapper rail king rail complex due to new genetic information, and it's thought that they're more related actually to Aztec rails. They're a protected subspecies in the United States. They were federally listed by U.S. Fish and Wildlife in 1970 and listed by the state of California, CDFW, in 1971. So since you all are up in the Bay Area, I thought I would go into some background on the Ridgeways rail as a species. So there are 6 subspecies of Ridgeways rail, 3 of which are located in the U.S. All 3 are federally and state protected. So the California Ridgeways rail up in the Bay Area are Ralis obsoletus, and the light-footed Ridgeways rail, Southern California to Baja, or Ralis obsoletus levapies, and as well as the Yuma Ridgeways rail inland in Southeast Arizona and the Salton Sea. And the California Ridgeways rail and the light-footed Ridgeways rail are quite similar. The California Ridgeways rail is pictured on top and the light-footed on the bottom. You can see that the breast of the light-footed rail is a bit more cinnamon pinkish, It's also noted that the dorsum of the light-footed ridge-raised rail is a bit darker, though in these individuals, that's kind of hard to see. It looks pretty similar. And the light-footed ridge-raised rail on average is a little bit smaller than the California ridge-raised rail. So historically, the light-footed ridge-raised rail ranged north from Santa Barbara County, south to Bahia San Quintin in Baja California, Mexico. However, they are currently believed extirpated north of Point Mugu. And here's the population estimates, and this is from the Recovery Plan Amendment. And you can see the population fluctuates quite a bit. And because it's a smaller population, they're pretty vulnerable to stochastic events. And notably, the y-axis is number of pairs, not number of individuals. And since 2018, the numbers are kind of in a steady decline. The latest estimate in 2023 is 266 pairs. And for comparison, the California Ridgeways Rail, this is also from the Recovery Plan Amendment. This is showing on the y-axis the number of individuals, not number of pairs. So it's a little bit different there. This is also from individual projects. It's not a range-wide survey, particularly the Invasive Spartina project, which has done a lot of the rail surveys in recent years. I couldn't find more recent estimates for a range-wide population estimate for California Ridgeways rails. And these are divided by recovery units, which is just a way of dividing population targets by the service so that you're not just targeting a whole range-wide population number, you have different pockets. So traditionally, the light-footed ridgeways rail nested in Spartina foliosa or Pacific cordgrass, and their nests were composed of Pacific cordgrass, anchored to and covered by Pacific cordgrass. And this is so the nests can rise and fall with the tide. They don't become submerged. They don't float away. And as I've been talking, you may notice that there's actually a nest in this picture right here. And we have a rail incubating on the nest. Also, after the incubation nest hatches, the rails will have brood nests for the chicks. So unfortunately, these rails face a myriad of threats. Habitat loss is a major one. Brophy all estimated that 75 to 90% of California's coastal wetlands have been lost since 2019, or since the, since the 1800s. And this includes an estimated 48 to 59% in the Southern California Bight. And this graph here, you can see the extant marsh acreage in red and the historic marsh acreage in white. Unfortunately, this means that the remaining habitat is highly fragmented, and this can have negative genetic effects like low gene flow, increased genetic drift, and inbreeding, especially in this subspecies that's not highly modal. It also means that there's increased predation pressure. As there's more marsh edge, predators have more access to the marsh. And the surrounding area is fairly urbanized, which supports a large number of mesopredators, as well as introducing predators that may not have historically been in the system, like feral cats. And the remaining habitat is highly degraded due to pollution, decreased tidal flushing, closed inlets, and decreased freshwater input. Much of the water in Southern California is highly channelized. And this is all exacerbated by sea level rise. So what is the outlook for the light-footed ridgeways rail? Well, Rosencrantz et al. 2019 projects that up to 80% of the rail's habitat may be lost by the end of the century. This graphic here is one of my study sites, Newport Bay. And as the sea level rises, you can see that there's nowhere for the marsh to migrate to because the surrounding area is highly urbanized. And so the marsh plain is lost and subsumed by the water. And in this particular marsh, there's also bluffs that prevent the marsh from migrating. This means that there's a loss of suitable nesting habitat. So already in Southern California, we have rails nesting in less than ideal substrates like pickleweed or close to the upland. We even have many rails nesting in tumbleweed or Russian thistle. This also means that there's a lot of refugia or places for the rails to hide from predators. Anecdotally, in Baja, there were 6 rails seen on a single shrub during a high tide event. This leads to increased access to the rails by predators. Some major rail predators are northern harriers, barn owls, but also many other raptors, as well as mammalian predators like raccoon, Virginia possum, red fox, as well as feral cats. And Casazza et al. 2015 found that 55% of rail predation occurred during a high tide level, only experienced 20% of the time within the marsh. And Thorne et al. 2019 documented increased avian predator activity during high tide events. So to look into the sea level rise a little bit more, this graph is from Rosencrantz et al. 2017. We have the Bay Area on the top left, Southern California on the top right, and the whole state of California on the bottom. And these are projections of the estimated remaining ridgeways rail habitat under different sea level rise scenarios. So the blue is a low sea level rise scenario, the orange is moderate, and the gray is high. So you can see it actually, it starts with a 0 baseline. So that was the baseline of the study. And going forward, there are actually increases in habitat under certain scenarios. But in the long run, particularly under the high sea level rise projection, a lot of the habitat, the majority of the habitat, or in some cases, all of the habitat may be lost. So this is from that same paper, and it's just kind of giving little snapshots of marshes you might be familiar with. The marsh that I mentioned earlier is in the bottom left, and the other 2 Southern California marshes are in the bottom right. The rest of the marshes are in the Bay Area. And the red and orange are high levels of suitable habitat. The light blue are low levels of suitable habitat, and the dark blue is mudflat or a complete conversion. So large-scale solutions are necessary to address these issues like sediment augmentation. However, in the interim, artificial rafts can supplement rail habitat and mitigate the issue. So here, this is that same study site, Newport Bay, and we have an artificial raft in the middle. And you can see there's really not much in the way of natural habitat during that high tide level. You can see a little bit on the edge by the upland. These rafts are placed in 7 Southern California marshes, beginning with Point Mugu in 1988. So they've been around a while, and they were originally placed for nesting. Overton et al. 2015 demonstrated that these rafts were used at a rate that's 300 times greater than their availability as habitat within the marsh. So another way of thinking about it would be that they're used at a rate that's 300 times greater than due to chance. And this study was actually done at with California Ridgeways rails in Arrowhead Marsh. They also found that different individual rafts were used at different frequencies. And in Southern California, we've observed that unfortunately the rafts are also used by rail predators. Particularly, we have a lot of issues with raccoons. So this is the artificial raft from the Overton et al. Study. That's in Arrowhead Marsh. I'm not sure of the current status of rafts, artificial raft use in the Bay Area. This is a video of a rail using the raft for nesting. And for high tide refugia, you can see that tide level in the background is quite high. And finally, a raft being used by a rail predator, the raccoon. So this led to my research question, which is if these rafts are being used, individual rafts are being used at different rates, how do we facilitate the use of rafts by rails? Predicted that the frequency of raft use by rails and rail predators would vary with abiotic conditions. So that includes things like elevation, biotic factors like vegetation characteristics or epifaunal characteristics, landscape features like distance to the nearest habitat edge or distance to the nearest channel where the rails are traveling. And second, that different variables would be predictive of rail nesting than of their use as refugia. And for the analysis today, I will be focusing on the first prediction. So to get at this question, I first had to quantify rail and predator use. So I did this using 4 different methods. The first was breeding season raft checks, and these are done at low tide on foot by a permitted rail biologist during the breeding season. So they're done every 3 weeks, and that's just to catch any nesting that might occur and reduce the impact that going too frequently might have on the rails. So we would approach the raft and from a distance check the raft with binoculars. And then if there's no rail on the raft, we would approach the raft and record any sign of use by either rails or rail predators. So that would include anything like arranged spartina, or in a lot of these marshes, there's not enough spartina, so they are using eelgrass or pickleweed, and they might have it arranged on there. And this on the right is a brood nest. Or in the middle, we have raccoon scat, so that's a sign of raccoon use, as well as large crushed crab pieces or tracks. And on the left is a rail pellet. It's actually a king rail pellet, but the Ridgway's rail pellet looks very similar. The second method was high tide raft checks, and these are conducted by boat with binoculars as well, so as not to approach the raft and bother the rail. And to see if any of the rafts are occupied during high tide. The third is historic nesting data. So the rafts where rails are nesting have been recorded for many years in each of those marshes where they're nesting. And finally, the focus of this analysis is raft camera data. So we put raft cameras on a subset of rafts at 2 of the marshes, just to get a finer timescale idea of how the rafts are being used. So we had cameras at 2 study sites. The first is Kendall Frost Mission Bay Marsh Reserve, and that's in the northeastern part of Mission Bay in San Diego. It's a small marsh. It's part of the UC Reserve System. And due to its small size, the population there fluctuates quite a bit. In recent years, there's been between 2 and 30 pairs. This fluctuation is also impacted by regular captive bred rail releases at this marsh. And there are 22 rafts pictured here. There are 4 cameras, and the camera placement isn't exactly random, and this is because the reserve used cameras that had a wireless connection to a hub, and that hub was located at this apartment complex here. So the rafts had to be within a certain distance. The cameras had to be within a certain distance of the apartment complex. Second study site is Upper Newport Bay Ecological Reserve in Newport Beach, California. And this site is much larger. It is 260 acres of salt marsh. There are 20 rafts here at 2 different subsites. So in the upper, we call that the Muth Center rafts, and in the bottom, the Upper Island rafts. This marsh used to host the largest subpopulation of light-footed ridgeways rails in Southern California. However, unfortunately, the habitat is declining a lot in recent years since 2016. And there's been a steady decrease of about 200 pairs since 2015, and only 36 pairs were detected in 2023. And because of this, during the course of the study, some of the cameras did not see use by rails. So we have cameras down here at Upper Island, as well as up by the Muth, but only the cameras by the Muth saw rails. So those are the ones that we have used in this analysis. So this is an overview of our data just to visualize. On the y-axis, we have proportion of days present by either rails in blue or raccoons in orange. And on the x-axis, we have the raft number. And you can see that different rafts are used at different frequencies by the rails. However, raccoon use looks a little bit more consistent. And this could indicate that the raccoons are using the rafts a bit more opportunistically. So to examine this a bit further, I used a generalized linear model, which is a flexible generalization of a linear regression, which you might be pretty familiar with, where you're looking at the correlation between 2 variables, but this allows you to incorporate multiple variables. So to start out with, I looked at a subset of explanatory or predictor variables. The first being percent open space surrounding the raft. So that's the open area that's not vegetated around the raft, the height of the vegetation surrounding the raft, as well as the density of the cordgrass. And I looked at the average number of prey species. So that's types of prey, which is more of a diversity metric than an abundance metric. The number of salt marsh snail and the number of California horned snail, both of which in diet studies have been found to be major prey items for the ridgeways rail. And those are both abundance metrics. So I conducted a stepwise AIC and found that the best fit model was that the proportion of time the rafts were occupied by ridgeways rails was best explained by the main effects of percent open area and the average number of prey species. And for comparison, the full model, so that's including these 2 main effects, but also the interaction effects between the 2 of them, so how they're interacting. And they have the same weight. So I chose the simpler model. And just to visualize this a bit, we have percent of days rails are present on the left, and the percent open space on the y-axis, percent open space on the graph on the left on the x-axis, and the average number of prey species on the x-axis on the right. But both of these trends are a linear combination of both of those explanatory variables. So the takeaway here is that as the percent of open space surrounding the raft increases, the use by rails decreases. And conversely, as the prey diversity or number of prey species surrounding the raft increases, the use by rails also increases. And so this is an odds ratio, which is a bit odd with our explanatory variables, but it's really just a way to look at probabilities. And both of these relationships were highly significant at the 0.01 level. So that's the asterisks. And it's basically saying, given a 1 unit increase in the average number of species, the odds of the raft being occupied by a rail increases by a factor of 1.74. Or given a 1 unit increase in the percent of open space surrounding the raft, the odds of the raft being occupied by a rail decrease by 0.85. So anything below 1 is a negative relationship, and anything above 1 is a positive relationship. Then we looked at raccoon use and found that the best fit model was that the proportion time occupied by raccoons was best explained by the horned snail count plus the average number of species plus the percent open area. And these are all main effects. But I ran repeated simulations of this data. So running probabilistic models basically to see if the model will fit. And most of the time, the data was falling outside of this envelope. So the envelope is these outside 2 lines. And this is just telling us that it's not a good model. It doesn't fit. So this could be that support for the idea that raccoons are using the rafts a bit more opportunistically, or that I'm just not looking at the correct predictive or explanatory variables. So that's something I'm going to dig into shortly. So what are the implications of this? So first, if you're placing artificial rafts, you really want to look at cover. And this makes a lot of sense because rails, they're eaten by many things. And in areas with cover, they're going to feel more protected getting to the raft. So the availability of prey is the second main effect, and this is a little bit more surprising. But it could be that in areas with a lot of prey, rails are spending more time in that area, and so they're attracted to rafts or more likely to find rafts in that area. It's surprising because rails are generalists, and food isn't generally thought of as a limiting factor. They can find food in many places. So another reason that this could be is that the prey diversity in an area is just indicative of good quality habitat. And the rails are spending time there because it's good quality habitat. So that's something I'm going to dig into. Also found that these rafts benefit other species. We have a sora using the raft below. And one important takeaway from this study was that these rafts were originally placed for nesting, and it was thought that in marshes where they're not nesting, that they're not getting a lot of use, that the rafts aren't doing that much. But this study really highlighted the fact that the rails are using these rafts really often for nesting, and it's very helpful to them because this is the time, refugia during high tide is the time that they're most vulnerable to predators, and having that supplementation of refugia can prolong their lives and help survivability. And anecdotally, I found that elevation might be important, and I'm going to look at this more in a model, but I observed that several rails would gather around a raft in a higher elevation area where some of the habitat was still available. And it might be that as the sea level is rising, the rails are going to those higher elevation areas, and rafts that are placed in those areas might be more likely to be used because the rails are already there. And you can see this was a scope photo, so it's a bit fuzzy, but the raft there's 2 rails on the raft and a couple of rails surrounding the raft. And in my study, as well as the Overton et al. Study, there were never more than 2 rails recorded on a raft. So it could be that the raft is, the rails are territorial over the rafts. And there's further support for this in this video. The agonistic display. So we just went over analysis on the raft camera data. And now I'm going to get into just a little bit of preliminary analysis on breeding season raft check data. So as a refresher, those are the breeding season on foot checks done by the biologist, so physical checks of the raft. And to start with this analysis, I just looked at Upper Newport Bay Ecological Reserve. And as a refresher on that, there are 20 rafts at 2 different subsites, so 10 at 2 different subsites. And all of those rafts are checked every 3 weeks. And I chose this study site because there's no nesting yet recorded at Newport. And this could be for a few reasons. The rafts are newer here. The second subset of rafts, where there are more rails, was just placed for my study in 2021. And the rails might take a while to get used to those and comfortable enough to nest on them. It could be that there's a high prevalence of raccoons at Newport. However, rails nest on rafts with high predator pressures in other marshes. Or it could be that there's surrounding habitat that's high enough quality that the rails don't need to nest on the rafts yet. But it makes it a simpler analysis because one of the assumptions of the model that I was using is that each survey is independent. So if you have a nest on a raft, that makes it more likely that you might detect activity of a rail on the subsequent check, which means that the surveys are not independent. So to look at this data a bit more, we have the number of positive detections. So there were 2 years of surveys conducted, 2022 and 2023. And there were 6 surveys within the breeding season, so late February to early August. So 12 total surveys. And you can see here that raccoons were detected a lot more frequently. So some were as many as 10 out of those 12 checks. It was also of note that raccoon use did not preclude rail use. So rails and raccoons were detected on the same raft. And we also had some rafts with no evidence, no detections. So there's a lot of numbers here, but I ran a occupancy model on the breeding season raft check data, and I'll kind of break it down a little bit. So because there are fewer sample sites, just because of the nature of endangered species and the number of artificial habitat supplementations, one thing I didn't mention yet is that they require a lot of maintenance. It's salt water, and it's hard to get something that's durable to stay out in the marsh. So we have broken each one down into its own model. So I have a Ridgway's rail model for 2022 and 2023, as well as a raccoon model for 2022 and 2023. So first we have the naive occupancy, and that's just the straight proportion of rafts that had detections on them. So that's exactly what we saw. And we have detection probability, which is basically telling us on an individual survey if a rail is present or a raccoon, what is the likelihood that we will detect it? So given that the raft is occupied, what's the likelihood that you'll detect it on any individual survey? And surprisingly here, the detection probabilities are quite similar between rails and raccoons. And this is a range of the actual occupancy. So you're taking the detection probability and the naive occupancy, and you're looking at what is likely to actually be there. So what proportion of these rafts are likely to actually be occupied? And it's a bit of a range. And in 2022, with rails, the range is a bit larger. And that's because we had relatively few detections, which might be because, as I mentioned earlier, the rafts were newer. Might take them a while to get used to them. And finally, here we have the probability of use given that there were no detections within the season. So it's quite low for raccoons, but relatively high for rails. So they could definitely be used without being detected. And the main takeaway from this is just that it's a wise idea to supplement raft checks with other methods of counting, quantifying raft use. So doing those high tide surveys or putting cameras on the rafts, because what you're seeing is just a tiny portion of the picture when you're just looking at raft check data. So it was thought that rails spending large amount of time on these rafts would leave evidence, and that's just not the case all the time, especially giving this occupancy model and then filling that in with the finer scale camera data. You can see that rails are using the rafts for large portions of time without leaving any evidence. So in the future, I want to look into abiotic conditions, particularly elevation that I mentioned. I have that data, I just need to add that to the analysis. As well as landscape characteristics for raccoons, I would really like to look at the distance to the marsh edge. It makes intuitive sense, but I also noticed that a lot of the rafts that are farther into the marsh had less sign of raccoons. Then I'll dig into those other methods of quantifying rail and raft use. So high tide raft checks. There's somebody searching for rails, and this is just the marsh plain on the left. So the whole marsh is underwater essentially, but the rails will hang out in this freshwater that's coming down from the runoff from the houses. There's freshwater vegetation. So this person's scanning for rails in there. And also look into that historic nesting data to examine whether the rails are using different rafts for nesting. And potentially, if there's some sort of link between years, if potentially the rail using a raft makes it more likely to be used in the future for nesting. I also have data logger data. I did not go into it as much in this talk, but the rails have the rafts have a wide variety of raft cover types. So some of them have artificial shade cloth, some have palm fronds, and some have fiberglass, and some are woven. And I want to look at the microclimate within those rafts, particularly temperature and light. So thank you very much for being here tonight and taking some time out of your Wednesday to hear about rails. I wanted to thank my advisor who made this project possible, as well as Dick Zemble and Sage Audubon that provided a lot of the funding for the project, as well as all the people at the study sites who were integral to getting those rafts out there and helping us study them.